Hello everyone, this is Harry Gill, and in this video we are going to look into some of the methods in the IOStream classes. The methods we will look into this session are the common ones that are present in multiple stream classes. In the previous video, we have already seen these hierarchies. So we have four abstract classes. So we have readers and we have writers. What we are going to do in this session is going to look into the methods that are present in these abstract classes and then the corresponding concrete classes that extend the abstract classes will have all those methods. So it's important to know those common methods, which is what we will discuss. The first method we will look into is read method. This method is present in input stream and reader abstract class. So this method will read the content of the file. So this will read 1 byte at a time. In the previous video, we have seen two types of input-output streams. We have a byte streams and we have character streams. Now you might think that if we are reading a byte or a character, why would this method, the read method, return an type of int? And the reason for that is we have also discussed a special value as -1 that represents the end of the stream. So -1 is an integer. So the Java creators have decided to use int type because it can hold a byte and it can also hold an integer, given the size of int is greater than the byte. So it can hold both types. So that's the reason why the read method returns int back. Similar to read, we have a method called write. This method is present in output stream and writer abstract class. This method takes an integer in. So whatever you pass in will be written into the file. Now let's jump into the IntelliJ and look into an example. Let's create a class called read write. In this class, I'm going to create a method called copy, and that copy method will read the content of one file, an existing file, and it will create a new file and copy the content to it. So let me create that file first. So new file, and I'll name that file as my file. And let me write a content. So this is the content of the file. I'll create a copy method. This method will take file input stream and also file output stream. So let's first read using file input stream dot read. Let me add the exception to the signature. So as we have seen, read returns an integer. So let me assign it to an int type. And now I'm going to write that read data into using the file output stream. So effectively what we did here is we read 1 byte from the input stream and we are writing 1 byte. So this will only read and write 1 byte. But what we want is we want to read and write the whole content of the file. In our case, that's more than 1 byte. So we have multiple bytes here. So what I'm going to do is I'm going to create a while loop. And I'm going to keep it storing into B. And I'm going to read it until we reach to the end of the stream and keep on writing that byte into using the file output stream. What I'm also going to do is I'm going to print whatever we read. And also I'm going to do a casting here. So B is of the type int, but when we print, I want to print the character equivalent, and I'll show you what happens if we don't do. Cool. So our copy method is ready. Now I'm going to create a file input stream, and I'm going to give the name of the file that I created, which is my file. Let's add the exception return to the signature. Now let me create file output stream. And in here, we will give a name of the new file. So let's give it as new file. Sorry, I have mistyped the type here. Now to the copy method, I'm passing the input and output stream. Also, let's add the exception returned from the copy method back to the main. Cool. Now let me run the program. There you go. So we have a new file. If I open, so we have the same content. So whatever we had here in the my file is now copied over to the new file. So now let's look into the output that we have printed. So as you see, we are reading and then we are printing, and this is the output we get. So we have read one character at a time. Now let me show what happens if we do not do the typecast. So I'll remove this and rerun the program. And you see we are printing some integer values. So these integer values are the ASCII equivalent of the characters. So if you just have a look at the ASCII table, you can search it online and see the 84 integer equivalent represents the letter capital T. The number 104 represents small h, and so on. And this is how we have read the whole file and written it. So now let's move back into our slide. Apart from these read and write methods, we have few overloaded flavors. For example, in the input stream abstract class, we have an overloaded read method that takes an array of bytes. What this method does is it will read the content of the file and put that content into the byte array that we provide. And the length of the content read from the file will be same to either the length of the array we provide, or if the length of the content is smaller in the file, it will just read the whole content and put it in this array. Similar to this, in the readers abstract class, we have a similar read method, but that takes a character array. And functionality is very similar. It reads the content of the file and puts it into the C array in this case. Now let's look into the writer side. So in the output stream abstract class, there is a write method that takes a byte array as an input. In this case, the write method will take the array's content, whatever we have stored in array, and store it into the file. And similarly, we have a write method in the writer abstract class that takes a character array. So it will take the content of the array and write it to the file. The only main difference between the output stream write and the writer array is that the first one is a bytes array and the second one is a character array. Functionality wise, they both are same. Let's jump into the IntelliJ and see an example. I'm going to create a class and name it as read write array. I'm again going to create a similar copy class. And this time around, I'm going to define an array of bytes. And I'm going to give a length of 50. And now when I read it from the input stream, I'm going to read it into the array. We did not discuss it in this slide, but this method returns an integer, and that integer represents how many bytes did the method read. Because we have given an array of 50, but there is a possibility that the file is not of that size. It might be lesser. So this read method will return an integer which will represent how many bytes did it read. So let's store it into int count, and let's also print it. And to write it into a new file, so I'm going to use file output stream, write, and give that array that we have read the data in. I'm going to create a new file, name it as my file2. Let's just copy the content of the previous one. And in the main method, I'm going to create the input stream, create the output stream, and then copy them. In here, I'm going to give the name of the new file. And a new file name while we write the content. Cool, our program is ready. Let's go ahead and run it. So our program has run. It says it has read 33 bytes. And you see there is a new file created called new file2. When you click on it, you will see it doesn't open in the editor. So just double click it, select the option of open matching files in the IntelliJ, select text, hit OK. And there you go. Now you can see the content of the file. But you will notice that the content of the file looks a bit funny because our original file looks like this, but we have some extra content in this file, and I'll explain you why. Let's go back to our code. So what we have said is we have created an byte array of the size 50. When we read the content of the file, the read method found that there are only 33 bytes. So it will put the 33 bytes in the index from starting from 0 to 32 of the byte array. The remainder of the elements of the array remains unchanged, which by default are nulls. And now when we go ahead and do a write, in here, we are writing the whole array into the content of the file, not just 33 bytes, because as of now, we haven't written any logic saying that the file output stream only writes 33 bytes. And that is why the content of the file looks a bit different to our original content. Now let's move on to the slides and see the other flavor that will fix this problem. Now the final flavor of the read method that we will look into is where in addition to the byte array, we will also provide two more arguments, which is an offset and length. What this does is it will read the content of the file, and when it comes to storing it into the array, it will store it in from that offset rather than from the 0th element of the array, and it will write up to the provided length into the array. And similarly, we have similar method of read in the reader abstract class. The functionality is exactly the same. In the writer case, because this is writing to the file, so this tells what content of the array is written to the file. So in here, we give an offset. This offset corresponds to the array that we have provided here. And we also say how many length or how many elements of the array will be written to the file. Same flavor is present for the character array as well. Let's move on to IntelliJ and see the example. So now I'm going to use the same program that we have just written. Let's start with the write. So in this case, we have said that take the whole array and write it to the file. But instead of doing that, I'm going to say that take the array, start from the 0th index, and write total of count elements into the file. And that count actually tells us how many did we read from the input file. So let's run the program. Let's go to the new file. So now in the file, as you see, we haven't written any special characters in the new file. And the reason is because this time we were very selective on what we are writing into the file rather than writing the whole array of length 50. Now, similar to write, we can modify or we can read. We don't have to read the whole content or the length of the array. We can specifically mention how many bytes do we want to read. And when we do that, we can say read the content of the file and store it from 0th element of the B array. And let's say we just want to take, we are only interested in first 20 bytes of it. Now, if I do that and run the program, so as you see, we have only read 20 bytes. Now let's look at the content, and we have only written the first 20 bytes of the content, even though the file was larger, but we were very selective on how much we read. In the real world, you will not be writing this kind of code. You will be using instead more high-level methods, which we will see in the future videos, but it's more for your understanding on how read and write works under the hood. Now let's jump into the slides and see the other common methods. The next method we are looking into is close. This method is present in all the 4 abstract classes. What this method does is it closes the file that we have opened. So whenever we open a file to read or write, doesn't matter, we reserve a resource from our system. So this resource is also referred to as file descriptors. A given system has only limited number of file descriptors, and if we keep on opening new files and don't close them, then we will end up in a situation where we will not be able to open any new files to read or write. So that's why closing is very, very important whenever we open. We haven't seen it so far just for the simplicity, but all the programs that you write to interact with the files, you should always close the file. Let's jump into IntelliJ and see how can we close a file. I'm going to create a new class called close example. What I'm going to do is I'm going to show an example what happens when we don't close a file. So I'm going to create a while loop, and it's an infinite while loop. Let's use an existing file. So maybe my file, doesn't matter what file it is. Also, I'm going to introduce an int I, and I'm going to print the value of this by incrementing each time so that we know how many times did we actually go through this loop. Cool. So what we see is that at some point our program ran and then we got an exception called file not found. And in the description, it says too many open files. So what we did here was we kept on opening new files, which is like kept on taking the file descriptor. And it seems my system has a limit of about 10,233. So note that this is not the actual limit. These were the free file descriptors that my program was able to use. In this case, like there are other files that my system has opened at the moment. For example, IntelliJ has opened this particular file. This is also using a file descriptor. So the main idea is that there are limited number of file descriptors and we can't leave them open. If you keep them leaving them open, this is called as memory leak, and we don't want memory leak in our programs. So to fix this problem, what we do is we simply, once we are done reading the content, so let's say read the content, and then we simply close it. Okay, now let me rerun the program. And now you see my program is running and it's going to run infinitely. So what I'm doing, I'm opening a file, reading the content, closing it, opening a file, reading a content, closing it, and so on. So this program will not end because of the while loop, it's infinite. So I'm going to stop the program. And in our case, so we have already read 968,000 times, but previously you have seen we got an issue, I think it was 10,000 off the top of my head. So this is the reason why we have to close a input stream. We have seen the input stream example, but same is true for output stream, readers and writers. So this close method is present in all the IO classes. Now let's see how to write this program in a more concise way. From Java 7, we don't have to explicitly write or call the close. There has been a new syntax introduced called try with resources. Let's clear out this. And the syntax goes something like this. So we have try, start of the bracket, and now we will open the resource that is needed to close. So in our case, that's file input stream. And we start a curly brace. And within this curly brace, we will read the content. So you can read, write, or do whatever in this particular try block. So let's say we do fis dot read. Let's also maybe just print it. And you can write any logic. So once the whole logic in this block completes, and when this close is encountered, then the resource opened in this particular case will be automatically closed. Now you don't have to explicitly call fis.close. So it's all taken care by this syntax. Now let's go back to the slides. So this is the last set of methods that you should be aware of. The very first one is mark and then the reset. So mark and reset go hand in hand. So when you call a mark, then the class will mark a pointer in your stream, and we need to pass a limit. So that pointer will stay active until that limit. You can call reset within that limit. And if you call reset, your pointer will reset back to where you had marked. And that limit is essentially number of bytes that you want to keep that mark active. You can only call mark and reset if a class supports it. And then there is a method called mark supported. So usually mark and resets are always written in a if block when mark is supported. Now the final one is skip. As the name suggests, skipping is essentially just moving the pointer and skipping n number of bytes and continuing on. Let's jump into IntelliJ and see an example. I'm going to create a new class. Let's call our class as mark reset example. Let's create a file input stream. And I'm going to use the existing my file. Now let's do a read. Let's also print it out. And let's not print the new line. Now, as I mentioned, we are going to use mark and reset, but to use mark and reset, we should be always calling mark reset supported, mark supported on the file input stream in this case. Now let's mark the input stream. And I have given the limit of 10. That means until I read 10 bytes, I can do a reset. So let's do a couple of reads. I'm just gonna copy paste. And now I'll call reset. And just for the easy readability, let's put a system out statement that mark reset is not supported. And now I'm going to do a few more reads. Let's do 2 more. And as we have already seen in the previous example, what we should do is put everything in the try block so that we don't have to explicitly close it. Cool. All right, let's do a quick run. Before I do, I'll show you what's the content of the file. So this is the content of the file. And let's do a quick run. So this is the output. Let me actually put a new line here and rerun the program. Cool. So what happens here is that we go here and we read T, which is printed, and then this returned false, and that's the reason why we came to this particular line. So it's a mark reset is not supported, and then we do 4 more reads. So we are reading 4 more times. So 1, 2, 3, and the 4th one is a space, which we can't see, but we have done 4 reads here. Now let's see what will happen if I don't use this condition and try to run the same program. Cool. So we do get an exception as expected. So the file input stream does not support mark and reset. So even though there is no compilation error, we will get a runtime error. So let's bring back our code. So this was an example where marks was not supported, and that's why we were simply reading T, and then we printed debug statement and then HIS in a space. So I'm going to modify the program. We haven't seen this new class, but for now, just modify the program, and instead of file input stream, we will use buffered input stream. And this is a high level IOStream class, so we'll have to provide a low level class here. So this is the wrapping we are doing. Accordingly, we will change this. Cool. Now our program compiles fine. Now let's run this and see what we get. So what happened here was that buffered input stream supports the mark. So in this case, so we came here, we printed T, and also due to this ln, we print a new line character. Now we marked a pointer. So this line prints H, and this line prints I, which is essentially this and this. We have already printed T, and then we call a reset. See, we had marked it after we printed T. So essentially our pointer was sitting at H. And now when we reset, our input stream had reset to that location. And when I do this, then again we read H here. And now I, and now we simply continue reading our rest of the text. So this is the concept of mark and reset. Now the final one, skip. Skipping is pretty straightforward. So we can do skip, and then we can say 5. So essentially we are skipping 5. And let's do a few more prints. Now let's run the program. So we had already read until space, and we skipped 5. So that means we will be skipping 5. So which is 1, 2, 3, 4, 5. We skip those, and then we do a print. This printed E, as we see here. So we print E, and we also print a space. We can't see the space here in the output, but that's what gets printed. So we print a space here, and similarly a space here. All right, so this is the concept of skip. Skip will return a long back, which will tell you how many characters or bytes has been skipped. Because it is possible that you can give a very high value here, let's say 5,000 in our case, but the content of the file is not big. So it will only skip maximum of like whatever content we have in the file. So if you ever need to know how many characters got skipped, you can always use that. This brings us to the end of the video. Thank you so much. I'll see you in the next one.